This is a video from the Exam 1 review in my linear algebra class. Let's take a look at number 6. Determine the conditions on B1, B2, and B3, if any, in order to guarantee the linear system is consistent. So here's the linear system. So we have x1 minus 2x2 plus 5x3 equals B1, 4x1 minus 5x2 plus 8x3 equals B2, negative 3x1 plus 3x2 minus 3x3 equals B3. And so what we want to do from here is set up the augmented matrix for this system. And so reading off the coefficients of x1, x2, and x3, we get 1, negative 2, 5, right? And then we put the B1 as my last entry. That's the constant on the other side of the equation. And so next row, we get 4, negative 5, 8, B2. And then the third row, we get negative 3, 3, negative 3, B3. And so what do I want to do with this system? I want to put this system in row echelon form. So we're going to perform Gaussian elimination. Could we put it in reduced row echelon form? Of course, but we just need to put it in row echelon form to determine the conditions on B1, B2, and B3. And so I'm going to rewrite this augmented system on the next page, and I have it right here, okay? And remember, I want to use row 1 to turn this entry of 4 and this entry of negative 3 into a 0. And so I'm going to take negative 4 row 1, add it to row 2, put the result back into row 2. I'm going to take 3 row 1, add it to row 3, put the result back into row 3. When I do that, row 1 doesn't change, and so I get 1, negative 2, 5, B1, so this matrix. 0, 3, negative 12, B2 minus 4, B1, and then 0, negative 3, 12, B3 plus 3, B1. Now, what I'm going to do is take row 2, add it to row 3, and put the result back into row 3. When I do that, I get the matrix 1, negative 2, 5, B1, 0, 3, negative 12, B2 minus 4, B1, 0, 0, 0, and then B2 plus B3 minus B1. Now, to be complete, we want to put this matrix in row echelon form, which means we need to turn or convert this entry of 3 into a 1. To do that, I'll take 1/3 row 2, put the result back into row 2. And when I do that, I get the matrix 1, negative 2, 5, B1, 0, 1, negative 4, 1/3 of B2 minus 4, B1, and then 0, 0, 0, B2 plus B3 minus B1. Now, the linear system is consistent, which means it has either one solution or infinitely many solutions if B2 plus B3 minus B1 equals 0. Or, solving for B1, we can say this linear system is consistent if B1 equals B2 plus B3. Now, make sure you're convinced of that. And what you can do is, from this matrix, you can write what the system would look like, right? So you can take x1 minus 2x2 plus 5x3 equals B1, and then x2 minus 4x3 equals 1/3 of B2 minus 4B1. And to write the third equation, we get 0x1 plus 0x2 plus 0x3 equals B3. Well, let me write it in order. So we're going to have B2 plus B3 minus B1. And remember, on the left-hand side of this third equation, you get 0. If this is a number over here that I'm circling, if that number is anything other than 0, this is an inconsistent system. If this number equals 0, then you have 0 equals 0, and that's okay, right? So we're really paying attention to that third equation. So, okay. So again, the linear system is consistent if B1 equals B2 plus B3. That would be the correct answer for this one. Let's take a look at 7. 7's a good question. It says, find all values of x for which a is invertible. Okay. And we learn about this some in section 1.7, and then remember, this is an exam, so chapter 2 is included, so we can apply chapter 2 as well. Now, A is the matrix x plus 3, x squared, x to the fourth, 0, x minus 5, x to the fourth, 0, 0, and then x minus 4. So I want you to notice something. Here's my main diagonal right here. Okay? Notice that the entries below the main diagonal are 0. Okay? The entries below the main diagonal are 0. That says A is what's called an upper triangular matrix. Okay? It's called an upper triangular matrix. So remember, a matrix, a square matrix, is either going to be invertible or it's not. Okay? So this is what I want to do. I want to determine the values of x that make A not invertible. To do that, I'm going to set the determinant of A equal to 0. Okay? Now, remember, A is an upper triangular matrix, so the determinant of A ends up being the product of the entries along the main diagonal. So in other words, the determinant of A is x plus 3 times x minus 5 times x minus 4. So I'm going to take x plus 3 times x minus 5 times x minus 4, and I'm going to set it equal to 0. Solve for x. We're finding the values of x that make A not invertible. And then A would be invertible for all other values. And so that says x plus 3 is 0, x minus 5 is 0, or x minus 4 is 0. Solving for x, we get x equal -3, x equal 5, or x equal 4, right here. So A is not invertible if x equals -3, x equals 5, or x equals 4. And so therefore A is invertible for all real numbers except -3, 5, and 4. And that's how we do problem number 7. And so that'll conclude this video for the Exam 1 review, and we looked at problems 6 and 7. Thank you.